Welcome to this tutorial on density and fluids. We'll be solving an exam question paper, and this is question B. Okay, you can kindly pause the video and attempt this question on your own. The question is saying a piece of wood of volume 0.6 meter cubed floats in water. So it simply means if you have a beaker of water, okay, and we have a piece of wood floating on the water. Piece of wood floats on the water, and we're trying to find the volume of the wood that is outside the water. This piece of wood is partially immersed in water, meaning to say the portion of it that is in the water and the portion of it that is outside the water. So the buoyant force, which is the force in fluids, is equal to mg in this case. So we'll say buoyant force, which is Fb, buoyant force, which is Fb, is equal to mg, the weight force. That simply means the density times volume times gravity, which is the buoyant force, will be equals to, since we're not given the value of m, the mass, we'll replace the value of m with PV. We are replacing with PV because the formula for density is mass over volume. Rho is equals to mass over volume. Mass over volume. So for us to make, when you make mass the subject of the formula, you should get density multiplied by volume. That's why we are replacing it with PV there, because we're not being given the value of m in the question. So we can cancel out g both sides of the equation, and the equation will remain with will be density of the fluid times the volume submerged will be equal to density of the object times the volume of the object. So we'll first find the volume that is submerged, which will be the portion of the wood that is in the water. Then we'll subtract it from the total volume of the wood for us to find the portion of the wood that is outside the water. So this will be PVS will be equals to PV, and making VS the subject of the formula, subtract both sides of the equation by the density of the fluid, which will be P with a subscript F, and we'll get VS to be the density of the wood times the volume of the wood divided by the density of the fluid. Replacing in the values that are being given, we'll find the volume submerged to be density of the wood, which is 600, times the volume of the wood, which is 0.6. That will be divided by the density of water, which is 1000. The volume submerged, when you do your calculation there, you find so the volume submerged in the water will be 0.3436 meter cubed. Alright, so I found the volume that is submerged in the water. Now the question is saying we find the volume that is outside the water. So subtract this value from the total volume, and we should get 0.6, which is the total volume, minus 0.36, which is the volume that's submerged in the water, and that is equals to 0.24 meter cubed, which is the volume that is outside the water. And that's how you find the answer in this question.